Hello everyone, welcome to Java Learners. In this video, we are going to talk about various features of a record which we could not cover in the previous video. In the previous video, we covered different types of constructors, auto-generated methods like equals, hash code and toString, and we also talked about instance variables and instance method in a record. In this video, we will talk about features like static methods and static variables in a record. We will talk about the inheritance in a record, whether it can extend any class or it can implement an interface. We will talk about nested records. Here we will see how we can define a record within an interface or within a class or within a record itself. At the end, we will talk about the serialization of a record and we will see how we can serialize a record and how we can perform the deserialization of a record. Let's talk about static fields and static methods in a record. In a record, static fields are used to declare constants, and these constants are used across all the instances of a record. In a record, static methods can be defined for various purposes like utility functions, factory methods, or operations that do not depend on instance specific data. In a record, we can also define a main method, and this main method can be used for testing purposes, and we can also demonstrate the functionality of the record using the main method. During the festive seasons, the e-commerce websites offer discounts on various products based on the category of the products. So I am going to implement the discount functionality in a record using the static fields and static methods. When an order is placed on the e-commerce website, then that order contains the product information. To represent a product, here I have created a record named product, and this product record has product name, product category, and its price. The product record also contains product category enum, and product category enum is defined in the product record because it is tightly coupled with the product. Here I have created another record named order, and this record has order ID, product information, and the quantity which is being ordered. This record also has a method named calculate total price, and this method can be invoked to get the total price of the order. In the order record, I am going to create one method named calculate discount. This calculate discount method will calculate the total discount on the order. Discount would be given based on the product category. So in the order record, I am going to create one enum map, and this enum map would store the product category and the discount that is applicable on that category. Here in the order record, I have defined the category discount map, and now I am going to create one method, and that method will add the product category and its applicable discount. Using the add discount method, we can add the product category and the applicable discount on the product category. Now we can provide the implementation for calculate discount method. So first of all, we need to get the discount which is applicable on the product. The product record contains the category of the product. So using the product category, we are getting the discount from the category discount map. So it is possible that the discount cannot be given on all the products, but the discount would be applicable on the certain products. The category discount map will contain the product categories on which the discount is applicable. The discount can be calculated using the total price and the discount percentage. So from the map, we have retrieved the discount for the specific product category. If that product category is not present in the category discount map, then the discount amount would be 0. And if it is present in the category discount map, then we have to use the discount value. So here we are done with our changes to calculate the discount on the order. In the main method, I have created an instance of product record, and I have also created another instance for order record, and in the order record I am passing the product record, and here I am calculating the total price of the order. Let me run the application and see. So here we can see that total price of the order is 20,000. Now we need to calculate the discount price. The order record contains a map, and that map is going to store the product category and its discount. And here I have added the product category and its discount. 0.1 means 10% discount. And after this, I have added the println statement, and here I am invoking the calculate discount method. Let's see what is the total discount on the order. Here we can see that the total price of the order is 20,000 and total discount is 2,000, because on the watches 10% discount is applicable. In a record, we can also define the factory methods, and these factory methods can be used to create the instances of the records. So here I have created one method named create, and this factory method can be used to create order instance. So we have defined the main method in a separate class. So I'm going to copy the main method from the main class, and I'm going to put this method inside the order record, because in the records we can define the static methods, and main method is a static method, and here we can use a static method for the testing of the functionality of the record. So if I run this, the output is same. Let's talk about inheritance in a record. Records are implicitly final and cannot extend other classes, but a record can implement an interface, and this interface can be any Java functional interface, or it can be any regular Java interface that we have defined. Here I have created a product record, and inside this product record I am going to create one main method. In the main method we will verify that a record extends java.lang.record. In the main method I have stored the class for product record in the product class variable, which is of type class, and then from the product class reference variable I am accessing the super class for product, and then in the println I am displaying the super class name. Let me execute it and see what is the parent class of product. So here we can see that the parent of the product is java.lang.record. Here I am trying to extend the object class in the product record, but it is showing an error, and the error is that no extend clause allowed for records, so the record cannot extend any other class. A record can implement an interface, and here we can see that the product record is implementing the comparable interface, and we have also provided the implementation of the compare to method in the product record. So record can implement any number of interfaces. Let's talk about nested records. We can define a record within an interface and within a class. And we can also define a record within a record. This feature is useful when we want to tightly couple the record with an interface or with a class or with a record. I have created an interface named order service, and within this interface I have defined a record named order. Now the question comes how we can create an instance of the order when it is defined within an interface. In order to create an instance of a record which is defined within an interface, we can use the interface name, and then using the dot we can access the record which is defined within that interface. Let me run the application now. So here we can see that the order details are printed. I have created a class named order manager, and within this class I have defined the order record. Now the question comes again how we can create an instance of the record which is defined within a class. In order to create an instance of the order record which is defined within the class order manager, we can write like this. First we need to write the class name and then dot, and then we can directly invoke the constructor of the order. And here we can see that the order is represented using the order manager dot order. So let me run the application and see whether the instance is created or not. So here we can see that the order instance is created successfully. Here I have created a record named order, and within the order record I have defined another record named product. How we can create an instance of the product which is defined within the order record. So inside the main method you can see that I have created the instance of the product by calling the dot product on the order record. And to represent the order we are also using the outer record name and then dot and then inner record name. So let me run the application and see whether it's working or not. Yeah, so here we can see that the product instance is created successfully. Let's talk about serialization of records. Like the regular Java classes, the records can also be serialized and deserialized. In order to serialize a record should implement the serializable interface. And the custom serialization in a record is not possible. In the regular Java classes, we can customize the serialization, but this is not possible in case of records. Here I have created a record named order, and this order record implements serializable interface. In the record, I have also defined the serial version UID. I have created two classes, serializer and deserializer. So using the serializer class, I am going to serialize the record, and using the deserializer class, I am going to deserialize the record. Let's have a look on the serializer class. Inside the serializer class, I have defined a method serialize, and in this method I am passing the order which I want to serialize, and I am also passing the file name where I want to store the serialized information of the record. And then I am using the IO classes to write the record information in the file. Let's have a look on the deserializer class. In the deserializer class, I have created a method named deserialize, and in this method I am passing the file name. By using the file input stream and object input stream classes, we are reading the serialized object from the file name, and then we are storing the serialized object into the order reference variable, and then we are returning it. Inside the main method, I have created an instance of order, and then I have displayed the order, and then I have performed the serialization of the order, and then I have deserialized the record, and then I'm displaying the deserialized record. So let me run this application. So here we can see that the order which we have serialized is matching with the order that we have retrieved using the deserialization. That's it for this video. Please don't forget to like, share and subscribe.